Namaskar students and welcome. In this video, we are going to see 7 science, lesson number 18, sound and production of sound. So let's begin. Vibrations are necessary. This we have seen in 6th standard also. See children, whenever any sound is produced, then the air column which is near the source of sound, it gets disturbed, and this is how the wave pattern is formed. And when these sound waves reach our ears or anybody's ears, we are able to hear sound. Vibrations are necessary for the production of sound. These vibrations travel through air and reach our ears. That's how we are able to hear. Here there are 3 people, children. They are playing 3 different type of instruments. This works on the air column. This works with the help of air. This is working on the strings. The strings are vibrating. And here the diaphragm, the upper part of the tabla, that is vibrating. So these are basically 3 different types of musical instruments. Sa, re, ga, ma, pa, dha, ni. These are the 7 notes of music, Indian music. Sound is generated by the rhythmic vibration of an object, and hence they show periodic motion. Whenever we are playing any musical instrument, if we know the tune, if we know the rhythm, then we feel pleasant to hear the sound of the instrument. If anybody is not knowing the rhythm, they are playing the instrument anyhow, then we will not like it. We will not find it pleasant. Terms related to oscillation. Now children, what is vibration? Vibration is basically fast oscillation. When any object is oscillating very fast, we say that it is vibrating. So a swing that moves back and forth is an oscillator. This is an oscillator, children. Here, this girl sitting on a swing, this is an oscillator. Here, this pendulum, this is an oscillator. And here, this rubber band which is going to vibrate, it itself is an oscillator. When the swing moves from one end to the other and returns to its starting point, it is said to have completed one oscillation. Suppose now if we start counting from here, it will go and it will come back. That is one oscillation. Here also, it will go and it will come back. The rubber band also, it will go that side and it will come back. It will go that side, it will come back. Not this much far, little bit. This back and forth motion of an oscillator on either side of the central position is called oscillatory motion. Either side, this side and this side. This is the central position. It is also called as the mean position. So this back and forth, back and forth, back and forth. This motion is called as oscillatory motion. Now, let's try to understand some terms related to this oscillation, or now we will say vibration. Amplitude, time period, frequency. What are these terms now? The maximum distance between the mean, which is the central position, and extreme position is called amplitude. From here, this part, this much is the amplitude. From here, this much is the amplitude. This amplitude is the same, children. Whether you take this half or you take this half, it is going to be equal. So, this is called as amplitude, the maximum distance which the object is going to move from its mean position towards the extreme position. The time required to complete one oscillation is called the time period of the oscillator. Time, children, we can calculate from this side, we can calculate from this side, we can calculate from this side. Suppose we count the oscillation from here. It will go and it will come back. That is one oscillation. So how much time is required to complete one oscillation? That is the time period. Frequency. Frequency is the number of oscillations occurring in 1 second. The unit of frequency is hertz. How do we measure frequency, children? In hertz. The sound is measured. The waves are measured in terms of hertz. What is frequency now, children? How many oscillations are completed in 1 second? That is the frequency. Now, is the length of the pendulum affecting the loudness of the sound or the vibrations? So the answer is yes. The time period depends on the length of the pendulum. It increases with increase in length and vice versa. That is why children, violin is more louder than the guitar, because guitar is bigger version and violin is a smaller version. So violin is more louder because if the length is more, then the sound is affected. The frequency is not affected with change in length of the pendulum, but the frequency is not going to change, children. So see the rigid support, this is the thread and this is the metal bob which we call as the pendulum. This is the length of the thread, length of the pendulum. Now, how loud is the sound? What is going to decide whether the sound is going to be loud or it is going to be low? Frequency decides the loudness of sound and pitch decides the sharpness of sound. Frequency means how the wave pattern is formed. Longer the length, higher is the frequency of sound, and vice versa. Sound is measured in decibel. If the length is longer, children, the frequency is going to be more. The sound is going to be more. Sound is measured in decibel. dB, small d and capital B. It was named after Alexander Graham Bell. This is Alexander Graham Bell, children. He invented the sound waves. Because of his name, children, we got the unit decibel. So children, here this is one activity shown in your textbook where we are trying to increase and decrease the length of the ruler, and then we are seeing whether the vibrations and the sound formed by the vibrations is changing or not. It is different, children. With a longer ruler the sound is more. With a smaller ruler the sound is less. Just try it yourself, children. Now, the pitch or intensity of sound. The tension in the length of vibrating object decides the pitch of sound. This tension. So that is why, children, we normally increase or decrease the tension in the wire, in the tabla to adjust the sound. Greater the tension, higher the pitch, and vice versa. Means if the tension is less, the pitch will be less. Loudness or softness of sound is indicated by two terms, intensity of sound and sound level. The intensity of sound is proportional to the square of the amplitude of vibration. This is just technical term, children. Means the sound is going to be proportional to the amplitude of vibration. Square of proportional, which means if the intensity is becoming double, the vibration is going to become 4 times. Square of 2. If the intensity is becoming triple, then the amplitude is going to be 9 times. 3 3s are 9. Square of 3 is 9. Do you know decibel levels of some common sounds? Beginning of audible sound 0 decibel when there is no sound. Normal breathing 10 decibel. Murmuring from 5 meters away 30 decibel. Normal conversation between two people 60 decibel. Heavy traffic 70 decibel. Ordinary factories 80 decibel. Jet engine 130 decibel, very loud. Start of ear splitting sound 120 decibel. From here the sound becomes too loud. Hearing is temporarily affected by sounds of frequency greater than 1000 Hz and levels higher than 100 decibel. This can result in temporary deafness. Workers who work near aeroplane engines experience this. So children, what is the range of our normal hearing? It is between 20 to 20,000 decibel. That's why we are not able to hear the sound of our breathing. Now children, let us see what are the different types of sound. Infrasonic sound means very low sound which you will not be able to hear. The frequency is less than 20 Hz. Low sound, it can't be heard. Audible sound. Frequency between 20 and 20,000 Hz. Sound can be heard. This is the range in which our ears, we are able to hear the sound. Not other animals, children, not other living creatures, children, because every living creature has got a different range of hearing. Ultrasonic sound, frequency more than 20,000 Hz. If the frequency is too much loud, then also we will not be able to hear the sound. Too high sound. out of our hearing range. This is ultrasonic sound. This ultrasound machine, children, it is normally used to see the pregnant fetus in the sonography. If somebody has got the problem with stomach, intestine, kidney, then also we are using this ultrasound machine. So this is using ultrasonic sounds, means its sound is so loud, too much loud, but it is so loud that it is going beyond our hearing range, so we are not able to hear the sound at all. That's why we consider it as a bit harmful, children. It's not such a good thing. Now, what are the uses of ultrasonic sounds? To clean delicate ornaments and tiny parts of a watch, to observe internal organs of the body, to detect tumors in the brain. We are using ultrasonic sound, children, ultrasound machine which I showed there, to detect faults in the metal, in radar systems, to kill certain microbes and insects, sonar, sound navigation and ranging. It is used by the ships, children. They are sending the sound waves and the sound waves are coming back again, and that's how they are able to find the depth of the ocean. That's how they are able to find the seabed. Sonar, sound navigation and ranging, is used to locate the seabed or the position of a ship. Now, this chart is showing the range of sound. Range of our audible sound, children. See, less than 20 hertz is infrasonic sound and more than 20,000 hertz is ultrasonic sound. We are not able to hear this sound, but bat is able to hear the sound. Dolphin is able to hear the sound. And the blue whale here is able to hear the sound which is coming in our range and which is coming in infrasonic range also, which means they are able to hear very low sounds. The pitch of sound is directly related to the frequency of sound. From the graph alongside, we get further information about the frequency of sound and infrasonic, audible and ultrasonic sound. So children, the pitch of sound is related to the frequency of sound. How sharp, how loud it is going to be. So this chart gives us a lot of information. So here we complete our lesson, children. If you feel these lessons are helping you, then don't forget to give a like and share it with your friends. Subscribe to my channel and give nice comments so that I am always motivated to help you all. Thank you for watching till the end.